books. Notebooks. Back again to square one. Nothing gets into the head. Then you see your marks, parents will wake up and then you're on fire. How come you're one behind today? Okay, so we have started with which lesson is that? Which one? You come there, beta. Shift on that side. Yeah, you come and sit here. Very comfortable. And you have a really problem. Right, because you want to copy. Comfortable there? Because you're okay. Come on, hurry up in that sheet. How long will you take? Now we have started. I want everybody to please pay attention. Okay? Like I told you in the very first class, almost about 90% of your learning takes place in the class itself. Take absolutely paying attention to what is being taught in the class. 90% of your learning is already done. Okay, so please be attentive in the class. And we are going at a very slow and a comfortable pace. I'm asking you questions. There are many times that you will realize that we are repeating. Okay. So that is for helping you to retain whatever is being taught. And the rest, 10 to about 15% depends on you, which you have to do at home, revise, re-revise, write down, read. That is the only way it can help you. So the last thing that we were doing was characteristics of metals and non-metals. Correct? So we see that when we talk about a metal and a non-metal, for every characteristic feature that we have spoken about, whether it is melting point, boiling point, okay, luster, right, sonorous, what is happening here? There has always been an exception, isn't it? Exception something. For every point, in fact, there has been an exception. So obviously, scientists realize by just looking at these physical characteristics. So what are these? These are the physical characteristic features. It is not sufficient for us to classify them as metals or non-metals. So then they begin to wonder, okay, what other things can be followed in order to say specifically that it is a metal or a non-metal. Visual, you're understanding what I'm saying? And you should also understand that we are talking about characteristics of physical and chemical properties way back in, let us say, 1700, 1800, right? And that was the time people did not know about the presence of atoms. In 9th standard, you have learned, no? Rutherford's model and stuff like that. Okay, Bohr's model. All those developments happened late in the 1800s. Okay, so later on, people realized that an atom of any element is made of positive charge, which happens to be present in the nucleus. And of course, we have got various electrons which are present in specific orbits. Okay, and we also know that the very first orbit contains 2 electrons, 8, 18, so on and so forth, maximum capacity. Right? So then they started saying, let us look at the chemical properties. Okay, how do we actually classify different type of elements based on their chemical properties? Okay. So we will just have a look at the periodic table. Now this periodic table was included in your textbooks. If you look at the textbook 2 years back, okay, this periodic table was included. So actually that was a very interesting chapter, because if you do periodic table, then this chapter becomes very easy for you to understand. Unfortunately, it is not there for your NCRT in your CBSE portion. But just for you to have a little idea, I have downloaded this part to give you a better idea regarding the positions of the metals and the non-metals. So whenever you look at the periodic table, there's no need for you to learn it, but it will give you a very good idea. You see that we can divide it into the left and into the right. Okay? You will see that all the metals are present on the left hand side. You see that? See, sodium, potassium, calcium, magnesium. Then we have got molybdenum, iron, cobalt, nickel, zinc, copper, etc. Silver, gold, mercury. All of them are on the left hand side. Okay? And on the right hand side, you find many of the non-metals which are present. Nitrogen, oxygen, chlorine, sulfur, fluorine, see carbon. Okay? So the periodic table itself is constructed based on the chemical properties. The last group here, we find that they are all noble gases. You know what is a noble gas or a noble gas? Helium, neon, argon, krypton, xenon, radon. See that? So it's a beautiful piece of the table, is just like a jigsaw puzzle, where all the elements have found the rightful places. Okay. Obviously, you will have to, when you take up science in the 11th standard, you have to do this, because you cannot go further. This is the basis of your entire chemistry which we are going to do. Why have I downloaded? Because now we see something about why electrons are lost and why electrons are gained, and based on that, how are we going to classify them as metals and non-metals. Are you okay? Okay with what I said? Did you understand? So the last point that you have written in your classification, what was it? Have you mentioned sonorous? Sonorous. What is sonorous? Sound. Whenever you take any metal and you hit it, it makes a nice ringing sound. So what is it called? It is sonorous. Okay. So add one more point. That is point number 8, I think. 7 or 8. Yeah, come on. Last point, 7? 8 point. Okay, whatever it is. So write down one more point, that metals are, make it as point number 8, and write metals are sonorous. It means they produce sound. Obviously, non-metals are not sonorous. We have written about electricity, heat, all that we have written. Okay. High melting point, low melting point, all that we have written. Okay. Now, if you have your textbook on page number 39, page number 39. Let's see here. Page number 39, we have a subheading called non-metals. Okay. We have already written the characteristic features of the non-metals. Correct? Okay, characteristics of the non-metals we have already written. Just make sure that everything has been written in your book. See, non-metals. In the previous class, you have learned that there are very few non-metals as when compared to the metals. Did you notice in the periodic table? A huge chunk of them are metals, which are on this side, on the left hand side. Very few of them on the right hand side are the non-metals. Some of the examples of non-metals are carbon. So what is carbon? Non-metal. Underline examples. Carbon, sulfur, iodine, oxygen, nitrogen. Fluorine hydrogen is an exception once again. Though hydrogen has atomic number 1, it has been put on this side. Okay, so that is the only exception here. Yeah. The non-metals are either solids or gases, except bromine, which is a liquid. Have we mentioned this point in your periodic table?
Hydrogen can be metal.
No, it's usually taken as a metal because it has a tendency to lose electron. Okay? But because of its property of being a gas, and in some of the cases it is considered as a non-metal. I will talk about it a little later. It's once again loss of electron and gain of electron. Sorry, what did you say? What did you say?
No, I was just thinking like to complete the octet, it can
Not at all.
use
No.
duplicate.
No. So it will be basically only a duplet. Okay, so it will either take up an electron or it may lose an electron. So depending upon what it is acting with, what it is reacting with. Right. So do non-metals have physical properties which is similar to that of the metals? Definitely not. We have already seen that the physical properties are entirely different. So in your notebook, everybody please write down difference between non-metals and metals was based on physical properties. All of you have written? Last time's table, this was based only on physical characteristic features. Write down this. On the top you can write. Where is yesterday's table? No, the book is not there. Why? You know there's a chemistry class today, no? How funny you can be. How many of you don't have the chemistry notebook? Why? How can you forget? By default, both of you, everybody, you please carry both your books. Okay, so you see table 3.1. We've already written element, symbol, type of surface, hardness, malleability, ductility. Did you see that? All that we have already written down in form of points. Right? On the basis of observations recorded, discuss the general physical properties of metals and non-metals. We have already finished that. Right? Point number 1. Who will read point number 1? Come on, read. Read me. Yeah, point number 1.
All metal except mercury exist as solid at room temperature. In activity given you have observed that metals have high melting. But gallium and ACM have very low melting points. These two metals will melt if you heat them on their palm.
Did you notice that? Have you written down the exceptions? What is it? Physical state. Check your table, everybody. Did you check your table? Notebook? Okay, have you written? They have got, most of them are present as solids. Exception will be mercury and of course gallium and cesium. So here you have gallium. So that is aluminium, gallium. And cesium you have here. So that's group number 1, that's group number 13.
And gallium is a metal.
It is a metal.
So why is it not the metal?
What did I talk? That there are exceptions to everything. Physical property is not going to give you a good idea because there are exceptions. It is a metal. Next, point number 2.
Iodine is a non-metal, but it is gaseous.
Okay. Have we mentioned iodine in our table? Graphite we have mentioned. Isn't it? Add iodine also. Did you write iodine? Written? Continue please. Yeah.
Third, carbon is a non-metal that can exist in different forms. Each form is called an allotrope.
Allotrope. Allotrope. Okay, what is it? Allotrope. Underline. What is allotrope? When an element exists in different physical forms, it is called an allotrope. Make a note of it in your notebook because we will be coming across it. Okay, go on to the next page. Don't disturb the table here. Define. I'm giving you the definition. When an element, this is the definition of allotrope. When an element exists in different physical forms.
And what is after element? As an element?
Exists
in different physical forms.
in different physical forms. Each form is called an allotrope. Each form, obviously, of the element is called allotrope. What is the example that we have already discussed?
Carbon.
Carbon. Yes. Carbon we have already seen that it can exist as diamond, it can exist as graphite, it can have coal of course. Okay, carbon or soot you can write, right? Then it can exist as fullerene. That are one example. Even if you mention diamond and graphite, is more than sufficient. Okay, example carbon, I put in bracket, it is an element. Okay, can exist in the form of diamond, graphite, etc.
Carbon element with
Carbon is the element, and these are all the allotropes of carbon. Did you understand? Now let's look at the periodic table. Do you know where carbon exists? Just for you to have an idea. See there? Can you see there? Carbon. That is group number 14. So that is a special. Okay, so carbon, phosphorus, sulfur, these are all having different allotropes. But not all of them, some of them have. Okay. Next point is, same point, you read the same point.
diamond and electron of carbon is the hardest natural substance known and has a very
1 minute, please come here. Come here, I said. You heard me, no? Yes, you can, please. That's why I said before I start the class, I wanted you to sit in different places. Quick. Okay.
is the hardest natural substance known.
Good morning. Ma'am, allowed you inside? Then? Mark your attendance outside and come in. That is if she allows. Speak to her. Spoke to Meena, ma'am? Continue, please.
Diamond and electron of carbon is the hardest natural substance known and has a very high melting and boiling point. Graphite, another electron of carbon, is the conductor of electricity.
Yeah. Did you write down all the points here? Okay, you have mentioned it, right? Definition of allotrope or what is allotropy is something that is going to be asked. Definitely. Okay. Next point.
And this is the same definition for allotropy.
Allotropy is the phenomena. Okay, when it shows such type of properties, it's called as an allotrope. Allotrope. These different forms are called allotropes of that particular element.
What is the last one?
This one, soot, maybe fullerene. Next one.
Alkali metals like lithium, sodium, potassium are so soft that they can be cut with a knife. They have low densities and low melting points.
Did you mention all of them in your table?
Yes.
Look at your table. It is very soft. It can be cut with a knife.
And alkali metals.
Alkali metals. Now once again, we refer to the periodic table. These are the alkali metals. Did you notice? They all belong to a similar family. Okay, just imagine there are members of the family. They have the same surname. Suppose you're talking about Agarwals or Sharmas. You have got everybody having the same surname. So all of them belong to a particular group. So their characteristics are the same. Lithium, sodium, potassium. Did you notice that? Why is it called alkali? Because it forms hydroxide, sodium hydroxide, potassium hydroxide, lithium hydroxide, and all hydroxides are alkali. Did you notice? So it's very easy to learn if you know something about the periodic table. Okay, now you understand? So make a note of it. Alkali metals. Now since they've already mentioned here, they can ask you a question, what are the alkali metals? Okay, that can be asked as a question or give examples of an alkali metal. Even though you have not learned the periodic table, you can be expected to write such type of answers. Okay, yeah. So elements can be more clearly classified as metals and non-metals on the basis of their physical properties. So last class we were discussing only about the physical properties, but now we know that there have been a lot of discrepancies, different type of exceptions. So now we will talk about chemical properties. Would you come here, beta? Got it? Clear? So now we'll read the activity. Now what is this activity? I'm giving you 2 minutes time. Everybody will go through the activity and I'm going to ask one of you to stand up and tell me what is happening in the activity. All of you have textbooks 3.8. Now we are going to be talking about activity 3.8. Have I finished? Asta is absent today. Only 4 of you are present today. Abhishek is absent. Done? Completed? No. They have given you an activity. I want somebody to stand up and tell me what that activity is. What are we doing? Ahmed, your turn. You. Yeah, what are the 2 things that we have taken? Okay, very good. At least you got it right. We have taken magnesium and we have also taken sulfur. We know to write down the symbols. What are they? They are elements. Look at the periodic table now. It's very easy for us to understand. One, we have taken magnesium. What does it tell us? Yes, these are metals. And where is sulfur? Right there. So one is a non-metal. The other one is a metal. Very good. Now what have we done? I may continue.
Burn the magnesium level.
Burn. What are we doing?
Burning.
Burning. That means what? Is it a physical change or a chemical change? Physical. You're burning it. Why? Why chemical?
The properties of the magnesium.
When you're burning, what is happening?
Oxygen combination.
Yes, it is combining. It's combustion. That means magnesium is combining with oxygen. Have we done this? Have we done this chemical equation? Yes. First chapter we have already finished. What is happening? Magnesium oxide. ये हो गया आपका magnesium oxide. Formula is what? Is it MgO, MgO2? Is it Mg2O? Oh, children, come on. No, I'm not talking balancing. I'm talking about the formula. Is it Mg2O? Is it MgO2? Or is it MgO?
MGO diagrams.
क्यों?
क्योंकि Mg2O2 है तो
Correct, very good. So you have got 2 plus and 2 minus, so this is the correct formula. So this is the correct formula, obviously it has to be balanced. Now it is unbalanced. Okay. What happens to sulfur?
it also combines with
Form what?
sulfur dioxide.
Correct. What will be the chemical?
SO2.
S plus, come on tell me,
Plus
plus what? O2. Will form
SO2.
SO2. Is it balanced?
Yes.
Yes.
Is it sulfur dioxide or something else?
Sulfur dioxide.
Sulfur dioxide. Okay. So these are the two products formed. What is the product? Magnesium oxide and sulfur dioxide. Yes, please.
Ma'am, under what condition sulfur trioxide is formed?
When excess of oxygen is present. Okay. So in both the cases, can you recognize is it displacement? What is the type?
Combination. Yes.
Displacement, double decomposition, what is it, blah blah.
Combination.
Combination.
Very good. All of you know that it is a combination. Ranmai, continue. Here you are okay. Sorry.
Exothermic.
No, this is endo.
Achha, sorry.
It is taking
Why
up.
we
You
subtract?
have to keep this. It is endothermic and it is a combination reaction. Continue.
Collect the ashes formed and dissolved in water.
अभी क्या करेंगे? What are we doing?
Mixing it with
This we are mixing it with water. This also we are going to mix it with water. Then अभी क्या होगा?
Test the resultant solution with both red and blue litmus paper.
Okay, so whatever solution is there, we were testing with red litmus and blue litmus. Why do we use a litmus paper?
To check whether
Whether it is acidic or basic. Okay. Now you tell me what is going to happen. No. You always remember, if it turns red, you know it is dangerous. So which is dangerous? Acid is dangerous.
Ma'am, then metal, basically metals are basic and non-metals are.
Yes. Correct. So it is a metal oxide. ये metal हो गया, ये आपका metal oxide है, and this will be basic. So what will happen to the litmus paper?
Blue.
The red litmus will turn blue because it is basic. ये क्या हो गया? This is a non-metal. Okay, it is a non-metal. It is an oxide of a non-metal. This will be acidic. So in an acidic क्या होगा?
Blue litmus.
Very good. So it is a blue litmus which is turning red. Always remember, if you are getting confused, it is red because it's danger. So you think about acids being dangerous. If you understand the activity in your exam paper, sometimes we will give you experiments like this. A small experiment is given, questions are asked, you are asked to read and write down. Do you understand? All of you, in your notebook. Activity 3.8. Okay, I have given you the entire activity 3.8. Write it down in your notebook. Write it in your notebook. Yeah. With reference to activity 3.8, I put M and N and all that. You please write down correctly. Otherwise, after 3 months, you'll forget what is M. What is M?
metal.
What is blue, red? If I write B and R, you'll remember?
Yes.
Come on. There. You write it down separately, there's no problem. I just written everything on the board. Write it the way you understand. Remember this, huh? We'll come across this quite often. Acidic oxide, basic oxides. Which acid is formed here when we say it is acidic? Yes, right. Sulfuric acid. Sulfur से आ गया sulfuric acid, sulfurous acid. Okay, H2SO4 sulfur should be there.
But actually not there.
क्या है?
Just पानी. So,
Done? Ujjwal, done? लिखा पूरा? After some time I'll ask you questions regarding this. Attend the class, okay? क्या हो गया? Fine.
Now, is there any exception like some metals are acidic?
There is one aluminium and zinc. They are called amphoteric oxides. We'll talk about it. Yeah, it is amphoteric oxide. Again, questions there. In text questions, ready? Rituraj, how come you have shifted? Textbook. Okay, read. Now your chance. Questions. And give me the answers also. Read the question and give me answer. Give an example of a metal.
At room temperature. Mercury.
Mercury at room temperature. Yes.
Can be easily cut with knife. Sodium. Is the best conductor of heat. Gold.
Silver, copper, anything you
Is a
can bring.
poor conductor of heat.
Not metal, no. They are talking example of a metal they have given on the top. So Pb, that is lead. Lead is not a good conductor. It's a very poor conductor. Not a, cannot say it doesn't conduct. It is a poor conductor. Likha answer, Mangmai. Likha nahi likha. What are you doing? Dreaming in the class? All of you noted down. Last one.
but then when a metal oxide reacts with water, it forms metal hydroxide, right? So what happens when a non-metal oxide reacts with water? It forms non-metal hydroxide.
What I did? I've told you now.
So it will form non-metal hydroxide.
It will form an acid. Here. Now we are talking about chemical properties of metals. So we have got some important metals. Usually we talk about. Last line there. Aluminium. Symbol क्या होगा? Al. Copper.
Cu.
Iron.
Fe.
Sure, Fe? Yes. Lead.
Pb.
Correct. Magnesium.
Mg.
Zinc.
Zn.
Very good. Sodium.
Na.
All of you know all the symbols, right? Okay. Now we have seen with respect to the periodic table that all these metals are on this side. Okay. Now we are going to talk about what happens when metals are burnt in air. Instead of using the word burnt in air, what is the other word we can use? Something else. Burnt, you're burning something. What is that process called?
CO2 combustion.
Very good. So what is it called? Combustion. So anything burning in air. So now you people are quite familiar. We know what is happening when metals are getting burned in air. Okay. So let's look at the activity. First one we have already done. You have seen activity 3.8 that magnesium burns with air with that dazzling white flame. You know what is a dazzling white flame? Like how apna Diwali mein we have those, we have those flares coming out. So that is here. Underline that word. Sometimes they will give you descriptive words and ask you to identify which metal burns with that dazzling white flame. So that's your question.
It's also given in the question.
Yes. So please read your textbook very carefully. Put a cue there. Until I tell you, you will not move your pen. You don't read them. Activity. Okay, look at the activity. Read carefully and will ask you questions. Next activity 3.9. What are the metals that we have taken? All these metals that they have given in the last, yeah, aluminium, zinc, lead, etc. And we are talking about combustion.
No.
Mm.
I used to.
I sent you outside now, no? Sit there. Done? Okay, there are a couple of questions. Now do all of them burn with the same brightness? Okay. Obviously not, because we know they're all present in different conditions. They're talking about the color of the flame. Okay. Next time I'm going to see if I can show you something with regard to the same experiment. Did you understand? But it is obvious that all the metals are undergoing a process which is known as combustion, which is reacting with oxygen. So what is going to be your general formula? Any metal combines with oxygen to form metal oxide. Please note that. All of you write it down in your notebooks. Now we are talking about the chemical properties of metals. It forms a metal oxide. Okay, one of the equations that we have already seen is magnesium oxide. Okay, the first one we have already done. Divyanshi, next one, can we write down sulfur plus oxygen is equal to sulfur dioxide here? Yeah, we can write down sulfur plus oxygen is sulfur dioxide. Can we write?
No.
Yes or no? You said yes. Yes. What is my heading? Sulfur is a metal or a non-metal? Non-metal. You can't write sulfur here. Samjha na? So you can't use sulfur because it is a non-metal. Now we are talking only about metals. Okay. Is this a metal? What is you?
Yes, ma'am.
Then there's no hesitation. Copper we know. Okay. We know this. Have we come across this equation? You have done it? Where? Which chapter? What is the equation? Redox reactions. है ना? Complete this. Come on, everybody. Whatever it is, you have already completed this.
Quick line.
This is quicklime.
CU.
Cu is Ca. Calcium is different. Copper is different. This we have already done. क्या होगा? Copper oxide. Correct. Copper oxide. What is the color? Children, come on. Blue. Turn your pages and see now. I'm not going to tell you. Come on, quickly. Color. Not green.
I'm black, ma'am. Black.
Black. Copper oxide is black. What is the color of copper?
Reddish.
Yeah, this is reddish brown. Oxygen. Okay, so copper oxide. Balancing. Yeah, there's 2 here, so we put it 2 there. Okay, come on, write down. You must know. Copper 2 oxide. Okay. What is the color here? Remember. Okay. Once again, I'm writing all these things so that you remember. This is a black, right? And here it is reddish brown. Now, can you recognize the type? Swarnil, what type of a reaction is this?
Combination reaction.
Everybody knows this is a combination reaction. So this is combination, this is combination, and endothermic. Can you recognize something else? Redox.
Yes.
Yeah, yeah. Very good. Yes, very good. What is getting oxidized?
Copper is getting oxidized to copper oxide.
Very good. Copper is getting oxidized to copper oxide. So this is your oxidation. Okay, so now there are different ways to express this. It is a combination reaction, it is an endothermic reaction, it is also an oxidize, it is an oxidation because copper is getting oxidized to copper oxide. Okay.
And won't this be an exothermic reaction?
Endo.
No.
Endo is you're heating it better. Suppose this is copper, okay?
But the heat will release, man.
Which will release,
The
right?
heat will release.
Why will it release heat? You have to heat it up, only then it will combine with oxygen. Oxygen is present in there. Okay. If I'm just keeping the copper, just imagine this is a strip of copper. I'm keeping it here. Will it form copper oxide? No. I have to take it up, I have to heat it, only then you will get the black coating. So what are we doing? We are supplying heat. If it is supplying heat, that means it is an endothermic reaction. Samjha? Are you clear about this concept? Okay. Finished? Okay. What is the next equation that we are talking? So in all these cases, these are all metal oxides. Okay. What did you mark in your book? Copper oxide ho gaya. Can we think of what is this now? Look at the board first of all.
Aluminum.
Okay. Once again, we are heating it. Suppose this is aluminium and I'm keeping it outside. Will it become aluminum oxide? What should I do?
Heat.
You have to heat. Okay. So what does it form? It forms a metal oxide. What's a metal?
Aluminum.
Aluminum.
Al2C.
Al2O3.
Al2O3.
Al2, 3. Why 3 here?
Because
value
aluminium.
Aluminium is plus 3. Did you understand? So aluminium is plus 3, plus 3. Oxygen is, so that is how when you cross multiply, you will get this formula. Okay, those of you who do not know, learn it up. This is very, very important. Now that we have got the formula for aluminium oxide, how do we balance? In your notebooks. Aluminium plus oxygen. Gufran, in your notebooks. Okay. Where, what do we put here? 2. 2. So aluminium becomes 4. Oxygen is how much? 3 2s are 6. So here 3. Very good. All of you got this?
Yes.
Virat got it? No. Yes? Okay, good. Now I want you to look at this equation because we have already got our product. This is a metal oxide. Correct? It is a metal oxide. Yes. When we say it is a metal oxide, is it an acidic oxide or is it a basic oxide? Abhi,
Basic.
it is basic, isn't it? We said it is a basic oxide. So this is a basic oxide.
All
When you
combustion
said-
reaction are.
When you said heat is supplied, right? So it is exo.
Endo.
No, when heat is absorbed, it is endo.
Endo. Yes.
But still it is a combustion reaction.
It is combustion.
So it will be exothermic.
See, basically what I'm saying is, for example, for magnesium oxide. Okay, you understand magnesium. You are taking a strip of magnesium. When you are taking magnesium oxide and keeping it on the table, will it start burning? No. है ना? अपना सुलसुलपत्ती also first you have to start, you have to supply. Once it starts the reaction, then it becomes. You don't have to keep on heating it. Because so much of heat is basically required. But initially to start, it is an endothermic reaction. You need to supply heat, otherwise the reaction will not start. Did you understand? Did you understand what I am saying? For example, coal. Okay? Koila. If you keep it there, will it start burning?
बनने के लिए heat देना पड़ेगा.
Did you understand? It will not heat, it will not burn on its own. You have to heat it up. Once the reaction starts, then of course.
Since all metals are in.
Not combustion. For combustion to
combustion.
start, you have to supply it. So, Janet, did you understand? Okay. Now, he said that metal oxides are basic in nature, but some of them have got a peculiar property, and let us see what happens here. Aluminium oxide, Al2O3, reacting with hydrochloric acid. This basically is an acid. We know hydrochloric acid is an acid. Can you tell me what is going to happen here? Aluminium will combine with chlorine. Then hydrogen will combine with
H2.
oxygen. Okay, tell me the formula. Aluminium
Cl3.
Cl3 plus
H2O.
Okay, now balance. This forms salt and water. Okay, so what is this?
Yes. Metal.
Metal oxide, not a metal. No, we are not talking
Metal
about
oxide.
metal. Yes. What is the dash which I have put? HCl is an acid. What is this?
Base. Base.
Base. If it forms salt and water, what forms salt and water?
Acid and base.
Acid and a base. So what is it acting as? It is acting like a base. So definitely we know that metal oxide is a base, so we have confirmed it. Now you think of the balancing of equation 1 by. Okay, tell me now. What's happening here?
Cl.
Why did you jump to 6 HCl? What about chlorine?
2 Al2O3.
2
Aluminium. We start with aluminium. How much is aluminium here? 2. Look at the steps here. 2 aluminium. So that is your first step. Chlorine becomes 3 2s are. This is your second step. This is your first step. This is your second step. Now hydrogen becomes 6. Here you put a 3 there. Okay, so that is your step number 3. Oxygen, of course, is balanced. Those of you who do not know are finding it difficult, put those numbers. You are copied it directly from the textbook. I have seen that. You did not try at all. You will never learn. By just copying it from the textbook, you will not learn unless you try it. Virat, put those numbers. How do we start? How do we do? What is the discussion?
I'm saying how we have balanced. Why we have balanced for CL.
How did you get 6 HCl then? How did you notice that it is 6? You will not know, no? It could be 8, it could be 4. How do I know it is 6?
With hydrogen.
Hydrogen, how do I know that it should be 3 here? Unless I put a 3 there. You look at 3 here for oxygen. You put a 3 there, then you will know hydrogen is 6. Then you put it. Either that way also is possible. Okay. Did you all get it? Okay. So this is your first of the equations. Now I am putting up a second equation. Okay. Aluminium oxide will also react with NaOH. What is NaOH? Is it an acid or a base? This is a base. Okay. So now it forms sodium aluminate. Did I give you sodium aluminate? Look at your last page. Right now, this is a new formula. NaAlO2. Sodium aluminate. Okay. So what is the valency here? This is +1 and this is -1. Aluminate. Now we balance. Now tell me, now it is a base. Since it is forming salt and water, what is this acting as?
Acid.
This is definitely acting as an acid. Now we try to balance this number. Is it already balanced? Oxygen is balanced, but then how much is aluminium? 3, 4, here it is only 3. So look at aluminium 2. Yeah.
But here 2, 3 in nature it is basic, right?
I'll talk about it. That's why I put up 2 equations here. This is what we will talk about now. Okay, I want everybody to try. Come on, try. Don't look at the textbook. Use your pencil, cut it out, do it again. Everybody must try, children. Sodium aluminate. What is the charge on sodium? +1. Aluminate? -1. Did you get 2, 3? What did you put? 2.
Yes, ma'am, done that.
Achita got it? Berabar? No? Serious. Aluminium is how much? 2. Look at the board. Aluminium is 2. Aluminium is only 1 here, so I put a 2 there. Sodium has become 2, so I put a 2 there. Okay, now let me count. Hydrogen is 2. 2 hydrogen. Look at the total number of oxygen. 2 2s are 4. 4 plus 1, 5. Here I've got what? 3 plus 2, 5. Therefore, it is a current balanced equation. Okay. Now I want everybody to concentrate on these 2 equations. Look at the board. Aluminium oxide in the first case, it's acting as a base. Aluminium oxide in the second case, it is acting as an acid. Did you notice that? Okay. So aluminium oxide is acting both as an acid and a base. Okay. Such type of oxides of metals are called as amphoteric oxides. Look at this word, Ampho. You know any animal which is staying in water and on land? What are they called? Amphi. It's an amphibian. Something that has got a dual nature.
So this is an exception.
Amphoteric is an exception. Amphoteric oxide is a metal oxide. Come on, take it out. Amphoteric oxide is a metal oxide. Example, aluminium oxide, which behaves, amphoteric oxide like aluminium oxide, give an example, which behaves
Oxide is the oxide. What is after oxide?
which oxide?
Amphoteric oxide is a metal.
It's a metal oxide which behaves like a base and an acid or an acid.
And what is after it behaves like?
Behaves like what?
Both acid and base.
Either an acid. It can behave as an acid or it can also behave like a base. So therefore it is called as an amphoteric oxide. Okay. Did you all get it? Got it? So come to page number 41. Now you are recalling similarly aluminium forms aluminium oxide. Did you get that equation in your textbook? Got it? Page 41. Got it, everyone? Right. Recall from chapter 2 how copper oxide reacts with hydrochloric acid, and we have seen that metal oxides are basic in nature. But some metal oxides, underline in your textbook, such as aluminium oxide, zinc oxide, show acidic as well as basic behavior. Such metal oxides which react with both acids as well as bases to produce salt and water are called amphoteric oxides. Okay, so did you get your definition? What are amphoteric oxides? One very common mistake that the children make while writing the exam is they'll write aluminium is an amphoteric. Aluminium is amphoteric. Is it correct?
Aluminium oxide, aluminium oxide.
What is
Sodium oxide.
aluminium oxide? Not aluminium. Aluminium is definitely a metal. What is amphoteric? It is aluminium oxide which is amphoteric. Did you see the mistakes? I'm also giving you the mistakes, okay, so that you remember that you don't make the same mistake. Also, yes. Another example is zinc oxide. Okay, did you all write down? Make a note of it in your book, everybody. Aluminium oxide, zinc oxide. Zinc oxide is also another exception which behaves as an amphoteric oxide. Why, what happened to that? Now we हो गया ना, another 10 minutes we are having a break. ठीक है? Put a tick mark in your notebook, textbook, everyone. Okay, one short question this is. Got it? Put a tick mark, right? Very, very important. Put a Q, whatever you want to put a star. Okay. Last paragraph there. Last paragraph. Raj, did you read? Last part. Raj, read. Most metal oxides.
Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to produce alkalis as follows. Na2O plus H2O gives NaOH, 2NaOH.
What is NaOH?
Sodium hydroxide.
So instead of reading in the form of formulas, can you read it in the form of words? Go.
Potassium oxide,
Okay. Acha, the second one you're reading. Okay, read.
potassium oxide plus water gives potassium hydroxide.
Very good. There's an AQ written. What is AQ?
Aqueous.
L is written.
Liquid.
S.
Solid.
You understood? Now, did you look at the periodic table? Where is sodium? Where is potassium? First group. Why did we call it as an alkali group? Because it was lithium, sodium, potassium. Did you see that? That's why that group itself is called as an alkali group. Next question. Come on, write down in your notebooks. Okay. One important point is most metal oxides are insoluble. Yeah. I can give it to you in the form of a chemical equation or maybe in the form of a multiple choice question, something. Okay. Then, first one. I want you to write down both the equations. Sodium oxide. I'm telling it in words. You write it down in the form of a chemical equation, balanced chemical equation. Don't look at the textbook. Sodium oxide plus water is equal to dash, forms dash. What will you write?
Sodium metal hydroxide.
Which metal hydroxide?
NaOH.
Sodium hydroxide. Come on, write it down. Balance it. Don't look at the textbook. Try to do it on your own. Sodium hydroxide. Virat, what is the formula?
Sodium hydroxide.
Balance it now. You'll come and write on the board. Why not? Of course you can. Next one. Potassium oxide. Next one. Next one. Potassium oxide. Raj.
Ma, the first equation.
Look now. No. Wait. Potassium oxide plus water. I'm already giving you plus water. Forms dash. Potassium oxide plus water forms what? Potassium hydroxide. Potassium hydroxide. That's all. What is the state here? Solid. This one?
Liquid.
And this is
Aqueous.
aqueous. Because it has dissolved, it has become an aqueous solution. Okay, it forms an alkali. Why is it called an alkali? A base, when it dissolves in water, forms an alkali. This is a base. Are all bases alkalis? Give reason. Think very carefully.
All alkalis are basic, but not all bases are alkalis.
Because not all metal oxides are soluble in water. That's what I've told you. Okay, for example, aluminium oxide, it's not soluble in water. It may be a basic oxide, but it is not soluble in water. Did you understand? All of you have written it down. Balance this equation now. What did you get? 2. So, oxygen is 2, hydrogen is 2, so therefore it is balanced. Similarly for sodium. Sodium oxide plus, correct, we form sodium hydroxide. Now, did you see the chemical nature? Did you see? Sodium, potassium, all of them are belonging to the same family. Okay? So they have got the same chemical formulas, the way they are reacting. Why do we have classification of flowering plants, non-flowering plants? Because the characteristic features are the same. Angiosperms, gymnosperms. Okay? Bryophytes, thallophytes. Why? Because the characteristic features are the same. Have you followed? So similarly, we are talking about the metals. They have all the similar characteristic features. Go on to the next page. Put a tick mark. Did you put a tick mark in your textbook? Move Frank.
Yes, ma'am.
Next paragraph.
We have observed in activity 3.9 that all metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. Metals such as potassium and sodium react so vigorously that they catch fire if kept in the open. Hence, to protect them and to prevent accidental fires, they are kept immersed in kerosene oil at ordinary temperature. The surfaces of metals
1 minute. Just underline that line. Metals like sodium and potassium are kept immersed in kerosene. Okay, put a Q there. I'm going to ask you why.
At ordinary temperature, the surfaces of metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of oxide. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but iron filings burn vigorously when sprinkled in the flame of the burner. Copper does not burn, but the hot metal is coated with a black colored layer of copper 2 oxide. Silver and gold do not react with oxygen even at high temperatures.
Okay, so they have given you basically about different metals and how they are reacting. Some of them react, some of them do not react. So obviously we know that metals are not reacting at the same rate when it is heated. But there's a very interesting fact there. I've asked you to underline. What is the question? Why should sodium and lithium be kept accidental fires? What else can you write? My question is, come on, take down the question. All of you write down the question. Okay. Metals like sodium and potassium are kept immersed
Sodium
in
and
potassium. Why are they kept immersed in kerosene? What will you write? Kaushik has already said to prevent accidental fires. What else will you write?
So that their melting point doesn't get below the oxidizer.
Read that part again.
Ma'am, so no,
Come on, try. Yes,
it's not
Raj.
a point, it's not a point.
Okay. Sunil, what about you?
So it will not react with oxygen.
You're coming closer. What else will you write? Yes, Kaushik. One another point is very important there. See that point.
man prevents them from oxidizing.
Something about the reactivity. How
Yeah.
reactive is it?
Something about to prevent them from reacting with oxygen.
Correct. So what is the nature of sodium and potassium?
Highly reactive.
Highly
This should
reactive.
be the first point. What is the first point you will write? Metals like potassium and sodium are very highly reactive. Come on, write down. Metals like sodium and potassium are highly reactive. Next point you will write. They react vigorously with oxygen and catch fire if kept in open.
And they react vigorously with oxygen and catches
And what?
fire.
If kept in open. Okay. So always we have a beaker or a bottle or whatever it is filled with kerosene, and your sodium and potassium is usually kept inside. Okay, I'll show you an interesting video on this next time.
Vigorously.
Okay, and vigorously is very important because it catches fire. What will happen? Chemical reaction, can you tell me now? If you are taking it out,
Na plus O2 Na2O.
very good. Did you get it? Sodium is reacting with oxygen, forms sodium oxide. So in order to prevent that, we have to keep it inside, or it is get immersed inside kerosene. Got it? In bracket, write down the equation so that you remember. Always in chemistry papers, wherever it is possible for you to give a chemical equation, must write it down. But it's this, right? Okay. Look at the question, some of the questions behind. I'm sure you will be able to do any of them by this time. Page number 57.
Now, Neil has a doubt.
Ma'am, in solids, if there is this pressure of 1 U atmosphere, so it converts into dry. So it is also an example of this question.
Dry ice is carbon dioxide.
Yeah, solid carbon.
Yes, solid carbon
So
dioxide.
when there is a lesser pressure, so it converts into dry. So it is example of this question.
No. This is not dry ice. We are not talking about carbon dioxide right now. We are talking about a metal catching fire. Okay. Look at question number 12. Look at question 12. Give reasons platinum, gold, silver are used to make jewelry.
Because they are very less reactive with oxygen.
They are
Like
Yeah.
they don't corrode easily.
There are different points. Very good.
Corrode easily.
You said something? What did you say? What is the word you should use? Malleable, ductile. Okay. Something else? Very good. Lustrous. What else?
So not corrode easily.
Very good. Very good. So what have we recognized? We have recognized the physical properties of gold and silver or whatever. Okay? Okay. Points equal. Don't write it as an important thing, just write down the important words that you should use. Question number 12, put a tick mark. Give reason. Platinum, gold, silver. Look at the periodic table. Look here. They're all metals. Platinum, gold, silver. Can you see all of them are together? Points to remember? Only the points, quickly. Ductile and malleable. Lustrous. And they do not corrode easily. Okay, they do not tarnish easily, they do not corrode easily.
Some they do not corrode easily. They are ductile and malleable and
Lustrous. They're having a shine, no? So therefore we are using gold and silver.
We will start with electricity in space.
You also have to electricity. Look at question number B. B question.
The answer.
Mami wrote it all.
You have already put. Okay, put the tick mark. We have already done. Look at C. Yes, Ruju, can you tell me? C. Yeah, aluminium. Don't we have aluminium pressure cookers? Obviously we have. Why? Yet it is highly reactive. Yes, but why?
So you will not, otherwise you will not be able to cook food. It will not be.
Think about the words. What word will you use?
Ma'am, it conducts heat.
No, because
Ma'am, aluminium is a.
Ma'am, it is a good conductor of heat.
that's solid. Good conductor of heat. Sorry? Aluminium is a metal. Metals are good conductors of heat. Okay. Point to remember, good conductor of heat. You have to mention that word. Okay, even though it is reactive, because we are talking about another point about anodizing that I have to tell you. Question number D we have not yet done. Question number 11 we can do. Put a tick mark. What type of oxides are formed when non-metal combines with oxygen? Kaushik? Which one? Look at the question. What type of oxides is correct? Which one? Acidic oxide. Can you think of two examples that we have done? Sulfur dioxide, we have done. Carbon is also correct. Carbon plus oxygen. Carbon dioxide. Hai na? Come on, write down in your notebook. Question number 11. Only the words. Write the answer afterwards. Type number 11. What is the type? Acidic oxide. And give two examples. Carbon dioxide, sulfur dioxide. Okay. Then question 6. Put a tick mark.
The examples will be aluminium oxide.
And zinc oxide.
Zinc oxide.
Two examples, aluminium oxide and zinc oxide. Then look at question 5. Rudra,
Question number
5.
You have a hammer, a battery, a bulb, wires, and a switch. How would you use them to distinguish between samples of metal and non-metal?
Yes. What do we have?
hammer, battery, bulb,
wires, and a
wires,
switch.
So which property are we using?
Conductor of electricity.
Very good. Is it
and
conducting
malleability.
electricity? And hammer में क्या होगा?
Malleability and
Malleability. You are hammering it. So whether it is malleable or not, whether you can draw it into sheets or not. Okay. So points we are testing is malleability and whether it is a good conductor of electricity. Okay. Then assess the usefulness. So you have to talk about what is malleability and what is ductility. And okay. Then, okay, look at question 3. See, did you realize almost 50% of the lesson is already covered because we are answering so many questions. Look at question 3. Rudra, read.
An element reacts with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is likely to be
Soluble in water, that is the key word.
Calcium.
Right?
Ma'am, because it is a metal and it is soluble. High melting point. Physics है.
So excited. अभी क्या किया हमने?
Next step is physics.
अभी क्या किया हमने? History रे, we have done history now. नहीं, we have done history.
He's asking we can take example as milk also. Because chemistry is there.
Like you can guess like तुझं बोलायचं
That your calcium is there in milk, so it is soft. So that's why.